In this video, we are going to find the volume of the water inside the cylinder given some solid object is inside the cylinder as well. Before we dive into this question, first of all we need to understand the shapes, different type of shapes and how does it look. Also we need to find the volume of these shapes and what is the equation to find this volume of this shape, and what is the curved surface area for these shapes. For example, here we have a cube. We know the cube, all the parts of cube are equal. For example, the length, the width, the height of the cube are equal. So that's why we have the volume of the cube A cubed. So let's go back to our question. The first step, we need to try and draw the shape described in the question to have better understanding of the question. So we are going to go and dissect the question part one by one. So to start with, it's written there, a solid consisting of a right circular cone. So the first shape we have is cone of height 120 cm. So we have the first variable given, h. h is equal to 120 centimeter and a radius 60 centimeters. So r we have 60 centimeter. So here we have the height which is given, and also the r radius which is given also. Standing on a hemisphere of radius 60 centimeter. So we have a cone which is on top of the hemisphere. Here we have the hemisphere picture and the r is given, also is equal to 60 centimeter. So let's try and draw this shape to have a better understanding. First of all, they told us it's a cone. So we will try to draw a cone. Okay. This is the cone. Then they said this cone is standing on a hemisphere. So how it's going to look like? We have to draw a hemisphere below the cone. Sorry for my drawing. Okay. And then we are going to continue with radius 60 cm. So the radius for this hemisphere and the radius of the cone, both of them are 60 cm. And they told us the height of the cone is 120 centimeter. Okay, so we are going to continue reading the question. Of 60 is placed upright in a right circular cylinder full of water. So both of these two shapes, the cone shape and the hemisphere shape, both of them are inside the cylinder. So we have to draw a cylinder, this shape inside the cylinder. We are going to continue drawing. I am going to choose different colors so you can see it more clearly. Okay, here we have the cylinder. It's going to be like this. Okay. And then sorry, this point it's supposed to be in the middle of the cylinder. Excuse my drawing. So the idea, we have a cylinder. Inside this cylinder we have a solid object, and this solid object contains of two shapes. One is cone, the second is hemisphere. So here they said right circular cylinder full of water such that it touches the bottom. So here we are supposed to touch the bottom, so I'm going to rectify it. It's supposed to touch the bottom like this. The cylinder is supposed to touch the bottom. Find the volume of the water left in the cylinder if the radius of the cylinder is 60. So now here, just to recap, the radius of the cone 60, the radius of the hemisphere is 60, the radius of the cylinder also we have is 60. The radius of the cylinder is equal to 60 centimeter, and its height is 180 centimeter. Height is equal to 180 centimeter. So here we have the height, and here we have the radius. So they need the water, which is the balanced water inside the cylinder here. This is the water which is inside the cylinder. They need to find the volume of this water inside the cylinder. So what we are going to do, we are going to find the full volume of the cylinder. Then we are going to subtract by the solid object which is inside, which is cone plus hemisphere. So step number 1, we are going to find the volume of cylinder. And to find the volume of cylinder, we are going to go back to our table. The volume of cylinder is pi r square h. So I'm going to write here, volume of cylinder is equal to pi r square h, which is equal to pi multiplied by r. R of this cylinder is here, which is 60 centi square, and the height is 180. So what we are going to get, let me use my calculator, 60 square multiplied by 180, 648,000 pi centimeter cube. Then we are going to find the volume of the cone. Going back to our table, the volume of the cone is 1 over 3 pi r square h. So 1 over 3 pi r square h, 1 over 3 pi, r is given, which is 60 centimeter here, multiply by h, 120. So we have 60 square multiply by 120 divided by 3. We are going to have 144,000 pi centimeter cube. Then the last thing, we are going to find the volume of the hemisphere. Again, we are going to go to our table. The volume of the hemisphere is 2 by 3 pi r cube. Two by 3 pi r cube. 2 by 3 multiplied by pi multiplied by r, which is 60 cube. This is the r, it was given in the question. So solving this, we are going to get 144,000 pi centimeter cube. So going back to our question, again I'm going to explain again in this drawing. We need the volume of the water inside, so we're going to take the total volume of the cylinder, total volume for the cylinder, minus the inner volume of the solid object of this. So the total volume of the cylinder is this 648,000 pi minus this, the volume of the cone, 144,000 pi minus the area of the hemisphere, 144,000 pi. We are going to get 360,000 pi centimeter cube. If we are going to change this to cubic meter, we have to multiply by 10 to the power of minus 6. So it's going to be, I'm using my calculator, 1.13 meter cube. So this is the final answer. 1.13 meter cube is the volume of water inside the cylinder. Thank you for watching.